What's up guys, Onmaths here, and today we're looking at accuracy. Now this is basically the opposite of rounding. So this is when we've rounded a number and then we've got to kind of work backwards to figure out what the number could have been. Like what's the smallest it could have been, what's the largest it could have been. So with this one, we've rounded a number and to 2 decimal places, and it's 4.76. Now the easiest way of doing this is just to draw a quick kind of number line and put the number that we've rounded to in the middle and figure out what the next one down would have been. So if it had been a little bit smaller, what's the next one down it could have rounded to? Well, that's obviously 4.75. And if it was a little bit bigger, what's the next one up it could have rounded to? 4.77. Simple as that. Now, where's the cutoff point? Well, the cutoff point is exactly halfway between the two. So here, and the cutoff point upwards is here. So the cutoff point for this one, well, what's halfway between 4.75 and 4.76? 4.755. And for the next one, it's 4.765. Okay, so you're just basically putting a 5 at the end of this one and this one. And that will pretty much always be the case. Pretty much. Not always, but pretty much. Okay. This is called the lower bound, and this is called the upper bound. And lower bound's the lowest it could have been, upper bound's the highest it could have been. Now, this is where things get a bit complicated, because you might be looking at this going, well, technically this would round to that. Okay, and you would be technically correct, but if you write the answer 4.7649 recurring for the upper bound, that is actually the same as 4.765. They're the same number. And the reason for that is that when you've got, so 0.9 recurring is actually the same as 1. Okay, and you might think, well, no, it's not. Well, if you think about it, 0.3 recurring is 1/3. And if you times that by 3, you get 0.9 recurring on the left-hand side and 3/3 on the right-hand side. Now, 3/3 just equals 1. So therefore, 0.9 recurring is the same as 1. It gets complicated. You don't need to know any of that, but if you're asked for the upper bound, you are absolutely correct in writing 4.765, even though that would round to 4.77. So you're absolutely correct in doing that. The Multiskim will always give you the mark for 4.7649 recurring. It will always give you the mark for that as well. But sometimes if there's other calculations to make, using the 0.49 recurring one, it's not the easiest to do. Anyway, I'm waffling because this question actually takes that into account, because when we write an error interval, we actually acknowledge the fact it can't be 4.765. So it says that the number is n, so we're going to put n in the middle. Okay. Now we know n, it must be greater than or equal to 4.755, our lower bound. So n must be greater or equal to that. It can be equal to that because that would round up to 4.76. But we know that n must be smaller than 4.765. But it can't be equal to it because we know that would round to 4.77. So whenever you're doing an error interval, this middle bit here, okay, apart from the letter, like the letter will be given to you in the question. If it doesn't say a letter, you can just make one up. I think all the ones I've seen have said use the letter n or use the letter x. That middle bit will always be the same with those inequalities when you're doing an error interval. And then obviously this bit is your lower bound. So that would be just the lower bound from the diagram. And this bit here will be your upper bound from the diagram. Right, moving on to our AQA question. Now there's a few bits of this question that make it very different to the previous question. The first thing is that the numbers that are rounded, so the original numbers, are whole numbers, so we don't need to worry about decimals. They're definitely going to be a whole number, and this time it's to the nearest 10, and they've got to add up to 70. So sum just means that they add up to 70, and we're looking for the maximum. Okay, so the easiest way to start this question is just make up some numbers. So I'm going to make up the numbers 10, 10, and 50. Now, the interesting thing about rounding, when you have this type of question, it doesn't really matter which numbers you pick. You'll get the same answer, oddly enough. So 10 plus 10 plus 50 is 70, so they add up to 70, so we can tick that off. And they're rounded to the nearest 10, so we've got to find the lower bounds, the upper bounds of each of them. And the reason for that is that we're looking for the maximum possible sum of the original three numbers. So we're looking to see what the biggest number that they were before. So we just think logically here, well, what could 10 have been before it was rounded? Well, the biggest number it could have been is 14. Now, again, you might be asking, well, why is it not 15, given the previous question? Well, if it was 15, it would definitely round to 20. 15 isn't 14.9 recurring. It couldn't have been 14.9 recurring. The biggest whole number it could have been is 14. And so the answer to this is 14. So obviously this would be 14. Highest number 50 could have been, well, 54. So if we add these up, then we get the answer of 82. So the biggest they could have been is 82. Now, if you pick different numbers, say if I picked, 20, 10 and 40, they still add up to 70. Then this would just be 24, 14 and 44. Notice it's always just plus 4 for each of these values, so it doesn't really matter which values you pick. It'll always add 12 to the 70 and give you 82. Last up is our OCR question, and this question has a calculation in it, so it's definitely within grade 6 territory. And the easiest way to start this question is just kind of ignore the rounding and just try and figure out what you're supposed to do with the actual numbers in the question, just ignoring the rounding. So we've got 7.5 litres of soup, and the soup is in 300 milliliter portion. So kind of my instincts first of all is convert this into milliliters, so we're using the same unit, so 7.5 litres, and we're going to times it by 1,000, so it'd be 7,500 milliliters. Okay, now that's how much we've got, and each portion is 300. So the calculation we'll be doing is 7,500 divided by 300. And I'm just going to do that on my calculator and see kind of what answer I'm getting, see whether it's within expectations, and that equals 25. Now, we only need to feed 24 people, so that leaves one left over. So you would thinking, yeah, okay, that's looking pretty good. But the point of this question is it's not a simple division question, it's about accuracy. So we've got to think what the worst case scenario is. So what's the worst case scenario for this? Like, it's asking us, does he definitely have enough soup? Well, the worst case scenario is if this is very small, as in there's not very much soup. Yes, we thought there was 7,500 milliliters, but actually the actual amount is much smaller. And the worst case scenario is if this is very big, that all the portions are at maximum portion size. So let's have a look at finding the lower bound of this and the upper bound of this, because that will give us our worst case scenario. So we've got 7,500, and we're looking, in fact I might do the number line because that's how I'm doing these. So we've got 7,500, and it's to the nearest half a litre. Now half a litre is 500 millilitres, so the next one down would be 7,000, and the next one up would be 8,000. So let's cut this in half on both sides. In fact, we don't need to do it on both sides, but I'm going to do it on both sides. So it'll be 7,250 and 7,750. And so we're looking for the lower bound, so that's this one here. So the worst case scenario is that the actual amount is much less than we thought. It's 7,250. Right, let's have a look at the portion sizes. So portion sizes, we are kind of assuming it's 300, but it's the nearest 10 mil, so the next one down would be 290, and next one up would be 310. And let's see the cutoff points for these. The cutoff point would be 295 and 305. And again, don't forget that that's technically 304.9 recurring, which is the same as 305. So that's my lower bound, In fact, we don't need that one because we're looking for the upper bound. We're imagining the portions are super big. So that would be 305. So we need to work that out. So that's just the worst case scenario, because it's saying, is there a possibility that it's not enough? Now, when you do that, you get 23.770, blah, blah, blah. Now, that is less than 24. So it asks us, does Sunil know that he has enough soup? Definitely have enough soup. Well, no. Is the answer. And don't forget to write the actual answer. Now, you could write a quick sentence saying that it could only be enough for 23 people, but all the calculations are shown for the examiner. So just make sure you answer the question, because the mark scheme will always hold a mark back if you don't say yes or no. So just write the word no. All the working out is there, clear to see for the examiner, and the examiner will give you 4 out of 4 if you show the working out nicely for them. Anyway, that is us done for today. So I hope you enjoyed that video. If you did, please click like. If you want to see more from us, we release videos every single weekday. That's Monday to Friday at 9 o'clock in the morning. Just click subscribe and the bell icon, and you'll be notified every time we release a video. Please keep your comments coming in. Summer school won't last forever because we will run out of topics soon. So any suggestions of stuff you want us to cover, let us know. If you haven't already, which I'm sure you have, check out our website onmaths.com. There'll be a card that magically appears at the top to take you straight through to the site. It's full of completely free resources to help you with your maths going forward. Otherwise, thank you very much for watching this video, and I'll see you tomorrow.